Hello, welcome back to Python Challenge for All. Now we have completed the journey about sliding puzzles. Let us just briefly summarize what we learned. So we first started to make the 8 puzzles, which we can play with our mouse or fingers, right? It was kind of easy. Let's quickly let look at the code. So using Pyxel, which is a very easy um, gameplay uh, tool, we can make graphic games easily. By importing Pyxel, we can make 3x3 games. Here, the important part is initialize the game, where the self game will make new games, which will kind of make 0 to 9 panels and then shuffle it. And then we can move it by, say, Pyxel button will enable us to move the panels. Okay, and draw will redraw the screen. So you can check the code carefully, which will kind of easily move the panels, and we can enjoy at least manually the games. Okay, so here the point is, okay, now we come back. Some games are solvable and others are not. Okay, let's say solvability conditions. So for 8 puzzles, inversion number was the key, where we calculate the inversion number, which is kind of a number of panels on the left-hand side of or lower side of the panel with larger number on it, okay, by counting the number of it. Even if when we move the panels, the inversion number remains, the parity of the inversion number stays same. So for example, look at this number. So it's always, however we move the panels, the inversion number, this number, is always stays at even. And this keeps until the board is solved. Okay, so this way we can make solvable games. So here we make iteratively generate games by shuffling the 9 numbers and then check the inversion number, and only if it is even we get out of the loop and start playing the game. In case of 15 game, 15, okay, this is how we can make 15 puzzles. In case of 15 puzzles with NN of 4, in addition to inversion number, we need to take row difference into consideration, which is how far the empty panel is from the goal position vertically only. So if the empty panel is at the lower corner, it's 0. If it is on this row, it is 1. It is on this row, it is 2. And 3 if it is on this row. So by adding these two numbers, we can check the solvability of 15 puzzles. Okay, so here, inversion number plus row difference. If the sum, the parity of the sum is even, then we can solve it. Okay, so here we can check the solvability. And here, okay, let's go back to the shuffling. Okay, we can make the shuffling by, say, let's check that. Okay. Okay, we can comment this out and we can make the shuffling. And this is solvable because the sum is even. Okay, and however we make the movements, the parity keeps the same, even. Okay, this is how we can make solvable games. And then I told you about 8 puzzles, how to solve it, how to solve 8 puzzles manually. And I think it was fun to take a look. Okay, about, yeah, like this. At least for 8 puzzles, we can solve it by keeping the rule. And after that, we started to make a solver of 8 puzzles. Okay, various AI searches. So AI searches uses search tree strategy to solve AI puzzles. So here, for example, yeah, as for 8 puzzles, let's make a fun of it. Okay, here, I think you still remember how to solve it. So put 1 at the left upper corner, and then maybe we can move the other panels 2 and 3 like this, and make, let's see, this is not good. Okay, like this way, we can solve 6 and 7, and then we can solve it. Of course, this solution was not good. As I told you in the course, the biggest steps to maximum steps to solve 8 puzzles is 30. So this is not optimal. Then we started to look for ways to solve 8 puzzles and then 15 puzzles. Okay? I will cover the explanation of those in the next session. So I stop here. Please enjoy yourself and come back again. Bye bye.